Okay, chapter 4, we're dealing with systems of equations. Um, you're going to have what we call pairs of equations. You have two unknowns, two equations. So when you have two unknowns and two equations, what you're going to have is you're going to have one solution. You're going to have possibly many solutions. You're going to have no solution because think about the equations themselves. And I'm going to start off with a very basic equation. These are lines. Remember, we could graph these lines. Okay, we could graph them and we could show the solution by where these lines intersect because they can only share one point. That's the most. They can be equations that have the same line, or they can be parallel lines and not intersect at all. So if I just look at this one, I'm thinking of two numbers that add to give me 5, but also subtract to give me 1. So if I had x is 3 and y is 2, well, 3 plus 2 equals 5. 3 minus 2 equals 1. So that is your point. That is your solution that solves both equations at the same time. That's what we're looking for. If I graph this, this is the point they would cross at. Okay? So this was the one we graphed with x plus y equals 5. So, I have this one here. Okay. So that is this line. And then if I looked at x minus y is 1, well, we know 3 and 2 is 1. 1 and 0, because 1 minus 0 is 1. So that's where they cross, and that's the point they share. Can't cross more than once, so there's only going to be at most one point of intersection. Okay, that's one way you can graph these. Now, there's two other ways to find this solution. So we're going to just look at this equation here and look at the elimination method, the addition method. Our goal is to eliminate x or y. Now, what we can do to eliminate them is we can add the equations provided we have opposites. Okay, well, plus 1y and minus 1y are opposites. So from here, I can add. The y's cancel out. I add the x's to get 2x. 5 plus 1 is 6. Solve for x and get x is 3. Then you can use either of the equations up here to find your y. So I'm going to use the one with a positive y because it's easier. So I know x plus y is 5. Put 3 in for the x. Subtract 3 from both sides. So y is 2. Okay, so that's the elimination method. Now I'm going to do a tougher one here shortly because I know that they're not this easy. But I just want to show it to you using something that's maybe a little bit easier to see. So that's the elimination. Now let's look at, well, how about if we wanted to do substitution? Well, substitution is a little more difficult up front. But then once you get your first answer, the second one should be a little easier to find. So I've got to choose one of these two equations and solve for either x or y. Now, solving for x or y does not mean putting 0 in for x or y. That's another thing. That's intercepts. So I'm going to take x minus y is 1 and I'm going to solve for x. Why? Because I'm going to add a y to both sides, which makes everything positive. So why not avoid the mistakes with negatives by trying to keep everything positive? So I just add y to both sides. So I get x is y, 1 plus y, or you can write it as y plus 1. Then I substitute y plus 1 into x plus y is 5 for x, because I'm saying x is y plus 1. So I substitute y plus 1 into here, write down the other y, and now I'm going to solve for y. So I have 2y plus 1 is 5. Subtract my 1 from both sides. 2y is 4. Divide by 2 to get y is 2. The good thing about this method is once I find y, I can put it right up into here and get x. So I know that x is y plus 1. Well, I know y is 2, so x is 2 plus 1, which is 3. So you've seen 3 different ways that we got the same answer. Okay? Now, oftentimes you're given an equation that you may not be quite sure what to do. Okay? So let's look at, let's say I had x plus 2y is 6, and 2x plus y is negative 12. Well, you can't just add the equations from this point because I can't eliminate anything. If I added the equations, I'd get 3x, I'd get 3y, and I'd get negative 6. That's doing me no good. So if I want to do the elimination method or the addition subtraction method, whatever you want to call it, I'm going to create opposites. If this was a negative 2, then I would have opposites in my x's. If this was a negative 2 here, I would have opposites in my y's. So I'm going to multiply one equation by something to eliminate, to get opposites. So I'm going to multiply the top equation by negative 2. And I have to multiply both sides. I'm leaving this other equation alone. Okay, now I'm going to simplify this and get negative 2x. I'm going to distribute. Minus 4y is negative 12. Positive 2x plus y is negative 12 also. I've just created my opposites here. So when I add the equations, the x's are eliminated. Negative 4 plus 1 is negative 3. Negative 12 and negative 12, be careful there, it's negative 24. Divide by negative 3 to get 8. So y is 8. Now I go back to any of the equations I've created, but I'm going to find x. This is the easiest one to find x because x is already by itself. So I take the x plus 2y is 8, or excuse me, is 6. Put in 8 for my y. So I get x plus 16 is 6. Subtract 16 from both sides. Be careful with your signs. And I get x is negative 10. you could have also done this first equation by the substitution method. So if I have x plus 2y is 6, and 2x plus y is negative 12, I can either solve the top equation for x or the bottom equation for y. Doesn't really matter. I'm just going to do the top equation for x. So I'm going to solve for x. So I do that by subtracting 2y from both sides. Okay, these cancel, and I get x is 6 minus 2y. I mean, you can leave it like that, doesn't matter. I'm just used to writing my variables first. So now I have negative 2y plus 6 is x. So I'm going to substitute this entire expression here into this x and multiply it by 2. So if you see what I've done here, this right here is now my x. I still have the y. I still have the negative 12. Distribute. Okay. Combine your like terms. Always combine like terms on both sides of the equation. Okay, be careful here, because when you subtract 12 from both sides, negative 12 minus 12 is not 0. Just think about it. You're taking negative 12, moving left 12 places, so you're kind of like adding another negative to it. That gives you negative 24. Divide both sides by negative 3, and y is 8, which is what we got doing the elimination method. Okay, so to find x, I take the value for y and put it right up into here, because x is 6 minus 2y. So once I know that, having trouble. Once I know my y, I can find my x. Okay, so don't forget when you list your answers, you know, even though we found x second, it's still the first coordinate. So this point where these two lines would cross would be negative 10, positive 8. Okay, so that's some helpful hints, hopefully, in chapter 4. But again, there's no substitute for practice. And as you're reviewing, as I've told you at least 5 times, you need to do the review without your notes, without help, and do it till you get it right. And then if you still have trouble, once you finish, then go back and look through your notes, maybe for some assistance. But don't, look at your note as you're working every problem. You won't learn it that way. All right, so good luck.